Hi, welcome to our final project for Computer Science 216, in which we use a machine learning model to predict points earned in a fantasy football system. This project was done by Kush Galati, Rob Haywood, Kevin Shaw, and Eddie Kim. Fantasy football is one of the biggest public things in the world. It adds a lot more involvement to watching sports and allows sports fans to feel more connected to every single play that happens in the games they love to watch. More than 60 million people play fantasy sports worldwide, a good portion of which includes NFL players, which is exactly what we were focusing on. In recent years, fantasy football has experienced exponential growth in popularity, and we now have entry fees funding massive pools used to reward winners of daily competitions and larger competitions such as March Madness brackets, in which fans compete with each other and many people that they don't even know to get the correct guesses. Even now, before big games, there are dedicated analysts who make predictions on what is going to happen on a day-to-day basis with fantasy points.
So what are fantasy sports? Using a lot of data, participants build virtual teams of professional sports players, and these virtual teams compete based on real-life player performances, which are collected and verified by computer servers that track the results and the performances of players in actual games. So we are focused on NFL players, and our team was particularly interested in predicting player performance, given several statistical predictors of player performance, such as rushing yards, touchdowns, passing yards, positions, and we compared our algorithms predictions to the projections given by expert fantasy football sources, such as NFL.com, ESPN, and Yahoo Fantasy.
So machine learning and fantasy football actually go very well together. Fantasy football has plenty of data to work with, and it allows us to kind of implement some really interesting machine learning models. Regression algorithms, which we'll go into in a little bit, can predict a continuous value. And one example of a continuous value is fantasy football points. So we use these regression algorithms to help predict fantasy performance. So why is our project substantial and relevant? Well, it's substantial because we use a pretty large data set to produce some robust predictions. And in turn, this can help things like sports analytics tools understand which player statistics are most important to then influence a predictive model. And it's relevant because fantasy sports is a fast-growing industry, and players and people alike, they're looking deeper for advanced analytics tools to help predict this player performance. And supply for machine learning solutions like in this space, in the fantasy space, is pretty limited. So we think this is a pretty relevant project to work on.
So our main research questions that we're looking to find answers to were how accurately can one predict the fantasy football performance of NFL players using machine learning? And the next thing we wanted to work on was figuring out which correlations can be drawn between variables and the fantasy football performance of NFL players.
So the main data source we used is Yahoo Fantasy Football. It's probably the most inclusive, most robust data set that we look for. And when compared to research tools and data available at ESPN, NFL, the ones at Yahoo, they're a lot more in depth in league history and then the fantasy-based statistics. And there's more unique weekly player write-ups and recaps. So overall, this data set is just a lot more inclusive and robust.
Due to how extensive this database is, we elected to implement only the top 300 players in the 2021 to 2022 season in our model. Additionally, once you get below that ranking, you start to get players who don't really make much of an impact on the field, maybe have less data available, and don't play many games. So we figured that the additional statistics such as percent of fantasy owners, preseason rankings, and final actual ranking would help a lot with the analysis of these more active players. In order to get this started, we started with the Yahoo Fantasy webpage, and they had a very nice table of all of these advanced statistics, which we wrote a web scraper for to capture these statistics, as well as 3 other web scrapers, which got team names, team images, and player headshots. And here you can see an example of what the table looked like. Where the ellipses are, there are many more columns, which you will be able to see in the final product, which is a website through which one can search for any of these 300 players and view their statistics, our prediction, and how far this prediction was off by.
So moving into some of our results, the main product that we wanted to build our backend on is a machine learning model. So the first thing we did was split our data into a 90 and 10 train and test set, just to ensure that we had enough data that we could train upon, and then also variables that we could test on. And some things that we did were implementing a regression model, which had a regularization component in it as well, which basically helps to prevent underfitting and overfitting and minimize the adjusted loss function, and basically take out any of the 25 variables that weren't being very predictive in our model. And we did this by running a alpha selection to basically find the optimal alpha value that minimizes this loss function. And our elastic net regression was run on the train data once we tuned all these hyperparameters the way we wanted to. And finally, to get our actual model, we did 10,000 resamplings of the data. So that means basically having 10,000 different pairings of train and test randomly sampled within our set. And we did that many iterations of the regression model and basically computed the averages on them to get the most accurate and conclusive parameters. So looking at some of the results that this gave, so we can see a distribution of player points, which is some of the data visualization we wanted to do at the beginning. It shows that the data is skewed pretty heavily to the right. So we have a much higher mean than a median within the data set. In addition, 5 out of the 7 outliers that you can see in this box plot were quarterbacks, which makes sense considering that they traditionally score the most points by position. And the last thing we wanted to look at was 75% of the players scored less than 171 points. And this basically tells us that most fantasy leagues are won by picking as many of the top 25% players as possible, because those are the ones that are scoring significantly more points than the majority of the data set. Now to look at some of the correlations between our parameters, you can see this heat map where we have all of our parameters compared with their correlations, and red basically says that they're strongly positively correlated, and blue tells us that they're strongly negatively correlated. So some takeaways here are statistics like pass interception, touchdown, and pass yards are highly correlated with whether a player is a quarterback or not, which checks out because only quarterbacks can record these statistics within a football game. And you can see the same thing with like reception yards and reception touchdowns for the wide receivers in our set. In addition, looking at the correlation between preseason ranking and actual ranking, they're pretty highly correlated, meaning that the Yahoo Fantasy expert algorithms did pretty well at determining how the players would do during the season because their preseason rankings are pretty close to what the actual rankings turned out to be.
So in this visualization, we essentially plotted 2 lines with our predicted points and the actual points with player rankings on the x-axis. And this essentially shows that our model does do a good job at predicting points when compared to actual points. Predicted points seem to slightly underpredict for the top 50 players and overpredict between players 100 and 250. We're not sure as to why this is, but we still feel based on the visualization that our model does a great job at capturing predicted points.
Yeah, and another way to kind of visualize this is looking at our model parameters. So since we scaled all of our data and ran bootstrapping as well as regularization, we can truly tell based on how high the coefficient is, like its magnitude, how predictive it is. So some takeaways here are that the predictive variables in our data set are passing touchdowns, actual ranking, and receiving yards, which makes sense because since quarterbacks tend to score the most points, their passing touchdowns highly correlate with whether this player is going to score a lot of points in a given season or not. And some of the less predictive variables are return touchdowns and positions where a player has played both wide receiver and another position. So this makes sense because return touchdowns aren't really factored as much into into scoring for a particular player. And finally, the y-intercept basically tells us that recording a 0 within all of these statistics, we get an average score of about like 127. While this isn't very realistic, this basically helps us skew the data towards having like higher values like 400 and 450 when we look at like the best players in the league. And finally, another way of kind of telling the actual versus predicted points, we plotted these residuals for our test set. And this basically says that our model has a root mean square error of like 8.35, meaning that our predicted points are within 8.35 of the actual points on the test set. And this really proves that our model is considerably better than Fantasy Football Data Pro models, which have an RMSE about 26.
So this is what the final product looks like. And in the next section of this presentation, we're going to show you exactly what it looks like. So here is the website. You can visit it at this link right here, which is additionally accessible in the README in our GitHub repo. So it's pretty simple. You can start off by searching for any of the 300 players that we decided to analyze. And here we have this auto suggest little box that helps you find one. So as an example, we'll go with Jonathan Taylor, who is a running back for the Indianapolis Colts. Here you can see statistics such as games played, pre-ranking, and other metrics which were scraped from the Yahoo fantasy database. To the right here is the points predicted by our model, the actual points, and we see that our guess was off by 12.4%.
So on to limitations. Our model uses the initial data set we saved in our GitHub folder because Yahoo decided to, since the season ended, they kind of the data isn't on their website anymore. And so we think this potentially reduces potential flexibility with other data sets. Our model also only uses data for the 2021 and 2022 NFL season. So it might be interesting to look at previous seasons and see if that can help better predict points. We also never conducted a full analysis of the statistical significance of each variable and how those variables kind of interact with each other and whether we're taking account omitted variable bias and whatnot. So that might also be a source of future work that we find interesting. Moving on to future work, gathering further data and testing our model with a more comprehensive data set that kind of better captures an individual player's performance, we think might be very important for the future. Looking into how accurately a machine learning model can predict other player statistics, such as fumbles and completed passes, might also be interesting instead of just predicted points. And also creating an algorithm to kind of produce an overall predicted rating for each player's kind of value add during the season, given their stats, might also be a really good like culminating project on the work we did. And yeah, thank you for listening.